Hello everyone, this is a video lecture for Pre-Calculus section 8.2, Graphs of Polar Equations. So I have a big note here at the very beginning. I recommend using a graphing calculator on all this stuff. Calculator, there you go. If you're using like a TI or Casio, make sure you're in polar mode and that you're in radian mode. Okay, they're two different modes. If you're on a Casio, you'd have to go to setup and make sure you're in radian mode. When you go to the graph y equals, you would do the you would go to r equals polar mode kind of thing. Okay, what I'm going to do instead is I'm going to use Desmos. So let's do some work. Okay, I'm going to write up a couple things, and it's not just all graphing, but I will be using Desmos a lot. But we'll also be doing a couple things by hand as well. R is equal to 1 plus 2 cosine of theta. Now I'm going to tell you that the book encourages you to go to a chart inside of the book, kind of recognize what form it is, lemnicons, lemniscates, rose petals, all that kind of cool stuff. And that's fun and all. Let's just do it. Let's just do it. So I go to Desmos.com, and this is what you come up with. Graphing calculator is the most common thing here. And you can do other things with Desmos, but that's what we're doing today. And I'm going to type R equals 1 plus 2 cosine theta. Now notice how I was typing theta, and then I was going to put an A. Ready? A, theta. And there you go. Well, I mean, that's your graph. I mean, they already say 0 to 2 pi, which is handy. You can change it if you really need to. There's your graph. Ta-da! That was it. That's the entire problem. I'm not going to even draw it. It's not even worth my time. You see it, you click it, you get it. There you go. R is equal to sine of 4 theta. Back to Desmos. So, R equals sine of 4 theta. And there we go. Little rose petals and stuff like that. Pretty little flower. I got 8.2.010. R is equal to 6 plus 12 cosine of theta. Back to Desmos. So I got R is equal to 6 plus 12 cosine theta. Now, notice that you could probably get the graph from just here, but I'm going to zoom out by scrolling out. There you go. Cool, cool, cool. On this particular problem, they're going to ask something else. They're going to say, where is it symmetric? Like, what kind of symmetry does it have? And we have some options: polar axis, pole, and then theta equals pi over 2. And you got to select which one. Let me tell you what they really mean. They mean the x-axis. This is the y-axis. This is the origin. Okay? Basically, out of these three, what would look best, or maybe two of them even, what kind of symmetry does it have? When you go back to Desmos, you can see that it's symmetric about the x-axis. Okay? Like, you know, the top side is the same as the bottom side. It's not symmetric about the y-axis because there's not a big old circle thing looking over here, so that doesn't exist. And then it's not symmetric about the pole because what happens is that it's kind of like a clock. If there was something here in quadrant 3, it would tick, 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 tick up until you get to quadrant 1. That's how I see it, at least. I'm not seeing that. Like, if I took this here and I rotated it 180 degrees, it would not be the same. It would not be identical. Okay, it would just be some kind of loopy thing over here. It needs to be literally on top of one another. So that is not the case. This is the best. The x-axis, or again, polar axis in their case. They just want to be fancy with their names. 82020. I've got theta is equal to 5 pi over 6. And they say, what's the graph of this? Now, we're going to go back and do a line equation here in a second, but let me just graph it for you. So notice that it was not r equals, it's theta equals. Theta equals 5 pi over 6. And nothing comes up. Wah, wah, wah. So how am I supposed to get the graph? How do I even know what's going on? Well, don't always rely on Desmos. Um, honestly, and you can't put this into your graphing calculator anyways. It was a nice shot. You know, we tried, but it didn't work. So what do we do in this case? Well, where is 5 pi over 6 my angle? Well, it's right there. But now I'm going to ask you, how much radius was there? Well, I don't have a radius. You're right. R could be anything. R could be everything. So I could keep going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 100 million, billion, whatever. I can also go negative. They didn't ever say that I couldn't go negative. Notice what we got here. Let me graph this for you as best I can. We have a line. It's a line. Wow, really? Yes, that's all it is. It's a line. So, and again, this is that 5 pi over 6 business here, which is, I think it's 150 degrees. Yeah, 150 degrees. Okay, cool, cool. That was great. Love the line. So they're wanting now the line equation in rectangular form. This is kind of an interesting thing. Remember, line equations are mx plus b. We got our slope and y-intercept. Well, b is going to be equal to 0 because, well, we're going through the origins. That's an easy thing. I just need to find my slope. Slope. Where have I heard slope before? Yep, it's tangent. Slope equals tangent, which is equal to y over x. Well, I have my angle. I'm going to say, okay, well, what's my tangent of 150? What's my tangent of the 5 pi over 6? Remember, y over x, you're going back to unit circle here, so my y value is smaller, my x value is bigger, but it's negative. The 2's cancel, and you basically get this guy right here is your slope. And you can keep going. What they have for their answer is a negative square root 3 over 3x, which is fine. My answer is equivalent. Notice again, plus 0 because, well, 0 for b. Either way works. They're both great. There's your line equation. Next question, 82022. They say r is equal to 6 cosine of theta. Graph it. All right. We could do that. So I've got r equals, sorry about that, 6 cosine theta. There we go. It's a circle. But notice about the circle, it's a circle that's touching here at 0, 0, and it's going out until what? Where's that going out until? 6. It's going out until 6. Kind of an interesting thing there. Also, it's along the x-axis, cosine for x. There you go. So there's my graph. They're wanting to rewrite it in rectangular form. I'm just going to give you the answer here. Honestly, this is my format for a circle, by the way. It's x is x minus, what do they use here? Like x naught? Let's use x naught. That's great enough. And then y minus y naught squared equals r squared. So that's my circle equation. I'm just going to go ahead and give you the formula. There you go. Well, where's my center? My center would be here at 3, right? 3, 0. So my center, I'm going to write that down, is 3, 0. That's, again, my x0, y0, x naught, y naught. And so then I got x minus 3 squared plus y minus 0 squared is equal to my r, my radius. If you go back here, notice that from the center I go out 3. So it's also a 3 squared. There is my answer. No need to simplify. Next one, 82024. By the way, this formula here is in the next chapter. I'm just they're wanting to talk about it. I can go ahead and give it to you. So pretty easy. R is equal to 4 sine of theta. Okay. R equals 4 sine theta. Notice it's a circle. Nope, there we go. Notice it's a circle. Its radius is 2, but it goes up until 4. Up. Y value. Sine. All related. And then finally, on this page at least, 82029. I got R is equal to 2 sine of 2 theta. This is pretty interesting. They want to chart what this is. They go and use those tables and say, oh, well, this number is bigger than that number. They are the same, and then blah, blah, blah. This one's an even number versus an odd number, and lots of stuff to talk about. But, well, there's your graph. So, Pretty cool. Pretty cool. No need to worry too much here. If you're wondering, like, oh no, I can't use a graphing calculator on the exam and stuff like that, by this time in the class, this is on your final exam, and the final exam allows for a graphing calculator, and I've been told that Desmos is a sufficient graphing calculator. So if you want to use Desmos, well, it's free. So, well, there you go. Oh no. Oh no. Okay. Pause, pause, pause. Okay, we're back. You didn't see any of that. So anyways, r equals 3 minus 4 cosine. We're going to graph this thing. Ah, computers. You know how they go. You're getting that lecture experience. That's what this is. Informal and everything. Wow, look at that. So there we go. Another shape. That's really awesome. Another one. 8, 2, 0, 4, 3. R equals theta. Now they give me a little bit more constraint. They say theta is got to be greater than or equal to 0. Actually, that's it. So r equals theta, and then I can like change some stuff if I really need to. I don't think I need to, honestly. So r equals theta. Wow, look at that. It's a spiral. Okay. I think we might be done with the Desmos. Maybe. Here we go. 0, 5, 7. So I got x squared plus y squared all cubed is equal to 9x squared y squared. And they want to basically be able to graph this thing using polar coordinates. So we're going to go to polar. R equals blah, 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 blah. That's going to be the goal, at least. How do I even start? Well, this guy right here on the inside is r squared. And these guys I can rewrite as saying that would be r cosine theta squared, r sine theta squared. Cool. So this is now r to the 6, powers multiply, 9 r to the 4, right? How many r's do we have over here is 4. And then we got a cosine squared and a sine squared. So this is not a good practice normally when we're solving for things, but since I'm just simply graphing, I'm going to divide by r to the 4th on both sides. I would say this is near bad practice. That's nearing bad math, but it does work, and I recommend it in this particular case. To get r by itself, you can square root both sides. Now remember here that when I square root both sides, I should get a plus and minus answer, right? Yes. I didn't even put that on my notes here. Again, when you're graphing, this is going to be good enough for right now, okay? You don't really need this as far as graphing is concerned. So there's two things that I'm a little bit leery about already without doing the plus minus and canceling stuff. That's not a normal practice, I would say. They keep going a little bit more. Honestly, they say, oh, well, this right here could be rewritten as, and this is where it gets just mind-boggly, a 2 times a half times a cosine theta sine theta. You're wondering, why would they do that? I mean, wouldn't they just cancel out, right? Well, this guy and this guy together, I'm going to combine those two, 3 halves. These guys together actually make 2 sine of 2 theta. Okay, so now you can say, oh, well, this number's bigger than that one, or that one's blah, blah, blah. You can go and graph it, basically, according to what the book wants. But just between you and me, you can just say r equals 3 halves sine of 2 theta. I like to use the parentheses just in case. And so there you go. 4 petals. That was cool. Last question of this section. So I got 82063. I have it's a word problem. It's talking about a satellite, and so we got, I don't know, Earth or I think it's Earth, and the satellite is coming out at a radius and a theta. So got a theta, got a radius. There's a satellite, let's say, and they give me r's equal to 22600 divided by 4 minus cosine theta. Okay. In order to do this problem, you actually have to know the radius of the Earth. Like, and I don't know if they actually include that here, but radius of the Earth, it's just like a distance, how many feet are in a mile kind of thing. The radius of the Earth is 3960 miles. When you're really thinking about it, it's not too big. But the radius is, again, from the very center of the Earth outward. So this is an important number. Go ahead and stamp that in the brain because it's very important. They want to know where is it closest, where's the satellite closest to the Earth, and how far away would that be? So what's going on is that we have Earth is basically a perfect circle, and we got the satellite that's going like this. It's kind of coming out like that, okay? This is definitely a normal thing, having it far away and coming in real quick, like using gravity as a booster and all that kind of stuff. It's just, this is a very normal orbit for some kind of thing. Comets do this kind of thing, by the way. You got the sun, and the comet comes in like this, and it goes back out, and we'll see it another 10,000 years. So, something like that. Anyways, what we have here is this equation. What I would suggest you could draw is r equals 3960 and this guy together in Desmos, and then you can see that it's actually going to be closest over here. I'm not going to do that. You'd have to scroll out a lot. I'm just going to go ahead and tell you they're wanting the closest angle, and the answer is pi. Now, there's actually a lot more behind us. Like, basically, I'm trying to plug in zeros, pi over 2s, pi's, and all kind of stuff into this cosine and see when is it the smallest answer, I suppose you can say. And it happened at pi. There's a lot of ways you can do it, but that's just one way, or you can graph it and blah, blah, blah. Okay, so what I'm going to do now is take that and plug that in to the equation, or the formula, and I'm going to subtract it from Earth's radius to get 560 miles above the surface of the Earth. Now, this is where we would calculate, oh, is that too close to the Earth where it's going to hit another satellite? Or is it too close to the Earth where it might burn up in the atmosphere or lose its gravitational to something? Blah, blah, blah. This is important. So this is actually good math. This is applicable math even. So there we go. We're done. Thank you very much. Have a great day.